Hey guys, so welcome back. Yep, on the nice new bench we got a really small radio. This is called a Hallicrafters Atom. It's I believe a model AT-3. There was an AT-1, AT-2, AT-3 that varied basically by color. This greener one is supposed to be a 3, I believe. The 2 was red and the brown was a -1, although I think some of the paint's starting to come off and it wants to become a 1 next. So anyway, we'll just see if this thing works. We'll open it up and take a look at the back. Here's the back of this, and you notice it's got 4 tubes. So I guess there's such a thing as an all-American 4. So we'll just see. We'll see how this thing does. So let me bring you in a little closer, and we'll get to working on this radio from 1953, a tube-type radio from '53. Okay, before we get into this, I found the schematic on this. So here's your 4-tube layout, and so it's got a 35W4 rectifier. It goes straight into a converter, a 12AU6. It has no IF tube, IF amplifier tube. It's got one IF stage. We've got the detector audio, first audio, 12AV6, and then the audio output is a 50C5, and it's got a permanent magnet speaker. And looks pretty simple. So let's get into this. Okay, the line cord is non-polarized, of course. It's in not too bad a shape, but we probably won't be using it again. We'll see. All right, let's get into this. To service tubes, remove back cover by removing screw. All right. Note, if the set does not operate in 1 minute on direct current, reverse plug in receptacle. Okay, so this is AC/DC set. Yeah. Okay. We've got an external antenna. Front of chassis. Oh, that's the tube layout. Okay. All right. Well, they didn't give us a lot of room there. I guess what we need to do is remove the screw in the bottom to take it out. I guess we'll need to pull the knobs off the front. I'm always doing this backwards. So let's see, just want to remove. All right. So it still has hold. There we go. Look at this. Well, the case is pretty plain. It's in physically, it's in good shape. Doesn't look like it's broken anywhere. I guess it's bakelite. Okay, we'll be cleaning that up a little bit later. All right, our speaker. Bring you in a little bit. Speaker appears to be in good shape. Moves okay. I don't feel anything. It's got no holes or cracks yet. We've got a little loop antenna on the back. Boy, this is really low budget, huh? And then we got our tuning condenser here. Very stiff to turn. Got one IF. It's got all the tubes. There's the adjustment for the oscillator, I guess. Let's go inside and see what we got here. I think it's original? I don't think so, no. Here's the capacitor here. You can see there's tape here, so this capacitor has been changed. The rest of it looks original to me. No couplets. A two-section, yeah, it's two-section capacitor. What do you think? Should we go ahead and put power to it and just see how this thing does? I think we can risk it. I'll run it up on my variac and dim bulb, and we'll just see how we do. So let me get this thing kind of set up. When I bring you back, we'll give this thing a little bit of a power up and see how it does. Okay, we're ready to go to power up on this thing. We'll see how it does. I'm going to be going through isolation transformer. I've got my variac over here on the side. I'm going to swing your end. You can see that a little bit. So I'll be bringing up the voltage here. You'll see the voltage coming up here. The scale goes to 150 volts. This is an AC ammeter. It goes full scale as 1 amp. This thing says it's 30 watts, so I expect it to be, kind of in this area up here. But we're really using that to just watch to see if we've got a short and something's running away. I do have the dim bulb in the circuit. We may or may not see that. It just depends on how much we get going. So anyway, I've got it. One of the things I noticed is I'm not sure this is correct. This is supposed to have a on-off switch on it. Well, there is a switch there. There it is. Okay. All right. Good. All right. We're going to go for power up. Voltage all the way down. Coming on. And here we go. 10 volts. 20 volts. I don't see anything happening on current. So our series string may be out. 30 volts. I'm starting to get a little bit of current. 40 volts. 50 volts. Let me hang on there for just a minute. I can do this because I'm on an isolation transformer, but in case I touch this, I'm just going to try to rock the tubes a little bit here. I'm going to watch the ammeter and see if it jumps. It looked like it went away, didn't it? About here. 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 I don't see any current happening. So I suspect we've got either a blown filament in a tube, or not making good contact in a socket. So let me turn off, let me flip it up, and then we can start checking to see what we got. Okay, I've checked all the tubes, all of the heaters. They all seem to be good. It's a Hallicrafters tube. This is the converter, the 12AU6. So all the filaments check out as being solid in the tubes themselves. We may have some bad sockets, but one of the things I wanted to point out is that because this is an All-American 4, if you will, instead of a 5, they've added another resistor here and in this series string. So I guess what I need to do is check to see if that resistor is okay. Then the next thing I want to do is just see if I'm getting power into this in the first place. I did get a little bit of a drain, but that could have been maybe a leaky capacitor. There's a couple of them here. So let me just see if that resistor is got something across it. So hang on a minute. Just looking for continuity here. Okay, 120 ohms. Yeah, 120 ohms. Okay, but at least it's got continuity through it, so we'll check voltages later. Alright, so let me get this back in. We're going to check to see if we're getting voltage through. Alright, so let's go back to power up. Can you see everything? Yeah, okay. Power back down. Here we go. 10 volts, 20 volts, 30 volts, 40 volts. Getting just a small amount of current. We might be getting almost 1/10 of an amp. I'll bring it up a little bit. 50. Let's see if we're getting 50 volts here. Okay. 39 it says. Let's try here. Okay, the switch seems to be working. So out of the switch it goes to a coil. That's weird. It goes to a coil. I don't understand that. Must be another lead here somewhere. Yeah, there is right here. Okay. 38. Yeah, check my voltmeter here in a minute. Let's see. So let's go to pin 3 of the rectifier. Am I starting to hear something? Yeah, it's making noise. Well, that's good. Let's give it some more juice then. It's coming up. Now, who guessed we'd have filter hum? Yeah, so we know a lot of good things here. Let me turn this off. Alright, so we know that the audio section is good. We know that, I mean, that's a big thing, you know, because the audio output transformers on these sometimes go. So what I'm going to do is, now that we know these things work, I'm going to go in and patch some capacitors in here to replace this filter capacitor, because that's all we're hearing is the hum from that. And I'm going to go get all that done, bring it back when I get that patched in. I'm not going to make it like permanent. I'm just going to attach it in to see if the rest of the radio works. So hang on, I'll get that done. Okay, I got the filter capacitors replaced on here. Got the big one here. We got two smaller ones here. There was three. There wasn't just two. We had the two that were in the power supply section. This pi filter that's here. Focus. Yeah, this pi filter right here. So we had these two, but the third one's up here. Is this cathode bypass capacitor right here on the audio output tube. Okay, so we got those in. I just tacked them in for now. This is just meant to be kind of temporary, you know, just to see if the radio is going to work. I did verify that this capacitor was not the original one. Let me zoom in here just a little bit, or get you focused. This one here was not the original one. What they did was they taken this and flattened this out, left the old ring in there because it's riveted, and then they just shoved that in to that hoop. So anyway, got this one removed, and I thought maybe, you know, everybody likes to see, is that capacitor really bad? So we'll test it with this ESR meter, and let me get it connected here for you. Okay. All right. Okay, so let's try this one here. More than 30 ohms. This one here, more than 30 ohms. This one here, also more than 30 ohms. So, yep, it was bad. All the sections were bad. We knew it was bad. We could hear it. We didn't need an instrument for that. But anyway, so we know, yep, it needed to go. All right, so we're going to see now how this works. Let me get you set where you can kind of see a little bit here. By the way, I've got this one in here marked with a yellow tag. That's the, just to help me remember, that's identified where the audio coupling capacitor is here. And then there's a chassis floating ground capacitor, or depth capacitor if you prefer, right here. That's located right down here at the bottom. And that won't be staying for long. Okay, let me get this thing set up to where we can start to see if we get some decent sound out of this now, or get something out of it. Let me get you set up here with the camera. Bear with me a second. All right, I think we're ready to go. Voltage all the way down, because I've been in there soldering on things. Let's go. Dim bulb's in the circuit anyway. Can kind of come up a little more aggressively. And let's see, there's 40 volts. Power's on. 50 volts. 60. Watch the amps here. It's a little over 0.1 amp, 100 milliamps. So there's 70 volts. By the way, my voltmeter's fine here. Where I had this connected, I had an alligator cord connected on the wrong pin of one of the tubes. So that's what the problem was. I've since checked it. My meter's fine. All right. I'm not hearing anything. 90 volts. Well, okay, let's talk about the good news and the bad news. The good news is we got audio, so the speaker's good, the audio output transformer is good, the audio output tube is good, the coupling capacitor is probably bad, but anyway, the audio section is still hanging in there. But I'm afraid we got Silver Mica Disease. We definitely got rid of the hum, but see, this is the deal. We wanted to go in and verify that the power supply hum was removed so we can move on with the rest of the repair on this. But the reason I didn't go ahead and start cutting everything out and everything is, you know, is this radio going to be something we really want to put the effort into? I never did get any radio signal. I think we got Silver Mica Disease really bad. Let me check to see if there's any way we can get any radio signal through this. But I think this is the problem right here. I'm going to reach up and go to my frequency generator here. And what I'm going to do is just try to pump the IF frequency into this. The IF frequency on this is 455 kilohertz. And so this should get through no matter where I have the tuning set up. And let's just see here. Turn this on. Can you see that frequency? Yeah. I'm sure that's close enough. Okay. 455. It's cranked all the way up. I hear it. I think I heard it turn on. I think I hear it barely in there. As you see, all I'm doing is turning the modulation on and off. I'm bringing down here and look at the radio. Okay, so I've got the loop right here. I could probably put it right over here. I got the modulation turned up so loud. This thing should be just blasting through this radio right now. So it shouldn't matter where this is tuned to. I think we got Silver Mica Disease really bad. Okay, I'll check a couple of things just to be sure, but I think that's going to be the diagnosis on this right away. So what I'm going to do is I'm going to try to put the signal straight in hot. Hang on. I've got capacitors of 0.01, and what I'm going to do is use this to block out any DC from getting back into my test equipment. And I'm going to attach it here to this external antenna port here. Okay, we're hearing that get through. So that tells us that there's continuity through the radio signal, through the radio system, but it shouldn't matter where this is tuned. Oops. See, it doesn't matter where I have it tuned to. Alright, so another thing we could do is, I mean, if that's not Silver Mica Disease, and we got like a really noisy resistor or something like that, but I'm pretty sure that's what we've got. We'll have to see if we can diagnose it for sure, but let me see if the oscillator's running while I'm at it. Okay, so in order to do that, the I should be able to put in a frequency like a radio station. And then if the oscillator is working properly, that means that that tone would still be able to get through the IF can when I have it tuned somewhere specific. Okay, so what I'm going to do is I'm going to go, you saw how that was running at 455, it was getting through at any dial setting. So what I'm going to do is take this and I'm going to switch up to, like, I don't know, 1500, yeah, let's say 1500 or so. I don't know how high the scale on this radio goes. It goes to 1620. Okay, so we'll go up to around 15. It says 1490. That's fine. So I'm going to turn the modulation on and turn the volume up. So now I should only be able to. Sorry. So I turn the volume up. So now I should be able to tune to that tone. I'm not hearing it. Shouldn't be down here. Should be up here. Okay, I'm not hearing it anywhere. I'm going to turn the frequency generator, just sweep it around a little bit, see if I can get any noise to come in. Yeah, I'm not hearing it. We may have a problem mixing as well. But all that frying bacon noise, that's Silver Mica Disease, I'm pretty sure. All right, let me switch this back to the IF frequency. Okay. Alright, so I'm picking up that okay. That makes me a little concerned about maybe the oscillator's not running, but it could be also a problem with, you know, the circuit messed up with the IF can being what it is. Okay, what I'm going to do is get my frequency, not my frequency, my signal tracer down. I can spit it out. Get this little guy out. He's pretty handy. And we'll see, connecting it to the common ground. And let's see. Turn this down. Now turn this guy up. Okay. Okay, that is coming out of the that's going to the IF can. Okay, we got a good strong signal going to the IF can. Let's see what's coming out of it. Well, I think we just solved it. So that's after the IF can. Let's go back to in front of it. Clean. That's the plate. Pin 5 of the converter. So that goes into the IF can, and so does this lead here. Okay. Then that's coming to the oscillator. This goes to the volume control. But this is the that there is the lead that goes over to the detector audio tube, and you can hear the noise. That's definitely a Silver Mica Disease noise. because it's building up a little bit. It kind of comes and goes. No. I'm just not going to cut it. Okay, I think our problem is Silver Mica Disease. Alright. So, this is an example of one of the things I talk about is fixing things before you put a lot of effort into it. There was a radio I did a while back, which was an Emerson, where somebody had gone in and done all the caps. And it looked like one of them they just like did a final soldering job and didn't even bother trimming the leads off of it. And you turned the thing on, it was completely silent. And it turned out the audio output transformer was burned up, and ended up having to completely unwind and rewind that transformer. Was it worth the time? No. Here's an example of, I went ahead and did the capacitors in here just so I could get rid of the filter hum. But now I'm 90% sure that what I've got is Silver Mica Disease in this IF can. So there's two capacitors in here that need to be removed. So I got to take that off, remove the capacitors, figure out what size capacitances they were, and tack a couple of other like Silver Mica caps down at the bottom. I've done this before. I've shown it on, there's a video where I talk about all the details of changing out the caps in Silver Mica Disease. But the question is is it worth it? You know, is it worth the amount of time it's going to take, you know, to get this radio back? Or is that like, good, we've got a parts radio for tubes. So this is a choice only you can make, you know, whether it's worth your time to do it. I could just say this project's done right here. I've done Silver Mica surgery on cans before. It's not like it'd be anything new on my channel to show. I could do it just to do it. I'll think about whether or not I'm going to do anything more about this. I'm going to sleep on it and figure out whether I'm going to do any more on this project or not. Because otherwise, that's really a pretty significant thing to go deal with. All right, so. Okay, so I'm sure we have Silver Mica Disease on this. It's the next day. So I've been thinking about it. If this was just me doing this radio, yeah, I'd probably put it to parts, but what good is it to make a video like this? So let's look at it this way. There's two ways we live this. One of these is that I'm saying this radio is probably not worth trying to put any more time into because of a diagnosis of Silver Mica Disease. It might not be worth the time to do it. Is my diagnosis correct? So let's see if it is correct. So I think what I'm going to do is I'm going to correct the Silver Mica Disease that I think is there and see if that fixes enough of this radio. It may still have other things going wrong with it, right? But the fact that I was able to get 455 signal all the way through means that modulated signal was also getting through the detector and that circuit as well. So, you know, the audio works, the volume control works and all that. So we got a good chance that if we deal with the Silver Mica Disease, this radio may come back. So that's a good reason to do it. We'll go verify that the diagnosis is right, and I'd like to find out too, to be honest. The other reason that we might want to be doing this is that, hey, you know, maybe this radio was given to your grandmother by her, you know, your great aunt for winning a spelling bee contest in 8th grade. I mean, who knows? There may be a reason why you'd like to get it fixed. And, you know, that happens. Most of the stuff I work on, you know, really for other people or for sentimental reasons, and that's where a lot of this really is, you know. If I was to be doing this to make money, you know, to repair this and then sell it, it wouldn't be worth the time. But for sentimental reasons, yes, of course. And also for just us being interested to find out, hey, did I get the diagnosis right? Let's find out. So I'm going to go in and do the Silver Mica surgery on this. I'm going to see how quickly I can do it. This isn't my first time of doing this by any means. And we'll just see how quick I can get it done. And I may leave the video running just a little bit, just so you can see maybe some bits or if something interesting happens. But otherwise, I'm going to go get it done. So what I'll be doing is I'll be removing the the intermediate frequency filter can that's right here, transformer. I'll be pulling that off. I'll show that to you when I get it off. We'll look at where the capacitors are in here that need to be replaced. We'll take a look at those. We'll see if we can get them out of here without destroying the whole thing. That'll be, of course, that might end the project there too. And then look at figuring out what do we think the capacitance needed to be in there. I'll do that before I remove them. And then see if I've got some mica caps that I can put on the bottom here to replace it. I'm assuming that we have a capacitor, I think, across here and across here, but I could be wrong. Let's see, does Schematics say there's more than 2? No, there's just 2. And I'll probably also, while I got it off, I'll stick a tool inside of the adjustment holes to make sure that the slugs inside are free to move, they're not stuck. Alright, so I'll get these all disconnected and we'll get into doing the silver mica surgery on this, and we'll make it quick. See that? Okay. You see that? We got all the leads disconnected now. Focus. Come on. You can do it. Please? Okay, there we go. Alright, they're all disconnected. I'll get the IF can now out of the chassis. Okay, you've got that one sprung. Okay, we're going to come right off with it. Okay, IF can is out. The green dot goes in this first location right here, right? And the paint's on this side. So the paint, the number is on the same side as the green dot. Okay, fortunately we've got a little schematic here that shows us which terminal is which connected here. I could do this by figuring out what went where. I should have written it down, but here it is helpfully for me. The green dot, I don't know if you can see it, is right here. Some green along the bottom of that terminal. So it's laid out like so. So 1 to 2 are these two right here. There's capacitor there, capacitor and a coil right here. And then 3 to 4 is the other one. So there's a pair here, and there's, I'm sorry, capacitor across these two and a capacitor across these two. Okay, so now what we need to do is try to figure out what is the capacitance of these. What is the capacitance of these right here? I know a lot of y'all say, you know, hey, they're 100 picofarads, just use it and it'll be fine. I hear you, but I've got a component tester. Because I can test it, I'm going to do so. All right, so what I have to do is, in order to get that, is I need to open this up and lift the lead on one of the coils here so that I'm just getting the capacitance in there, because I don't think the component tester will read both an inductor and a capacitor in parallel. So let me get this opened up. Okay, already got the pencil marks on there, that's nice. Okay, so let's go ahead and remove the coil from the housing. Here we go. Okay, we've got our two coils. Let's see how well you can see this. Wow. Yeah, normally you see a little bit of black that bring the connections together, and that's what's causing your shorting. This has just gone completely black, man. This is not. this isn't Silver Mica Disease. This is Silver Mica Death. Look at that. Glad I opened this up to look at that. I have never seen anything that ridiculous. Okay, so for those of you who don't know, the way this works is usually, this one looks a little different than some. Let me get this off and we'll just take a look at it later. But yeah, the capacitors are located, you know, basically between here and here, between here and here, and here and here. And these leaves are holding down on a piece of mica that's got silver plated on there, and usually it's a pad of a certain size. I imagine like an oval, kind of like an oval, and it's screen printed onto there, and these little arms go down, push right down in the middle of the pad, but there's another pad, there's a sheet of mica here and another pad underneath, and so that gives you your set area and spacing that gives you your capacitance between those two. Okay. And there's another one over here. This is the same thing. Well, what happens here is that you get a voltage going across these connectors, and the voltage creates a field that causes the silver ions to migrate across the surface of the mica, and apparently humidity can drive this faster than other times. So basically the silver ions start to migrate towards each other across the mica, and then as they start to touch, they start to arc the voltages, and that's where you hear all the crackling and all that kind of stuff. Here the silver's just gone everywhere. The black is the silver oxide, right? Like tarnish. Well, I don't know if I'll be able to get a measurement of capacitance on this or not. Let me take a look at this and see what leads I'm going to unsolder, and then we'll give it a try. Hang on. Okay, I'm going to try to unsolder these leads that are here and here. Let's see what I'm pointing at. I know you can't see them, but there's some little fine wires here, and I'm going to disconnect this one and disconnect this one. I'm going to have to get my magnifiers on, get in there and get those loose, so bear with me. So I know you want to ask me, what's the knack for this? Well, the knack is that the wire comes in and wraps around the post. And what you can do is you can grab it on top, above here, you can kind of unwind it around the axis of the post. So imagine you have the post like this. If I can find, okay. If you can hold it here, what you can do is kind of unwind like this, and it'll start to unwind it off of the post. So that's what we're going to try to do. Well, the trick is trying to figure out which way is it wrapped, clockwise or counterclockwise. Come on. Which way are you wrapped? Okay, there's one of them off. Okay, let's see if we can get this other one off. It's kind of tight looking in it. Let's see if I can get some slack on it. Okay. Okay, we got both those guys loose. Okay. Can you see any of that? So here is one of the leads loose right here. Sorry if it's not focused, it's about the best I can do. And then here's the other lead loose. Okay, so now I'm going to do is back up and we're going to test for the capacitance. See if we can get any reading at all. Okay, got a component tester here. Let's see, let's set this up where you can see. Bear with me a minute. Okay, can you see? Alright, so what we want to do is see if we can see capacitor from here to, I'm going to get a short, hang on a second. I just need to make sure that alligator clip isn't shorting against another terminal, okay? Okay, let's keep our fingers crossed to see if we can get him reading here. I tell you, that's so bad, I don't know if we're going to see anything here. That is so shot. We're not even getting anything there. Well, I guess I'm going to have to do what the internet says and go with like 100 picofarads. Let me try the other one. And then see if we can just tune it in far enough. Okay, there's the other one. Let's see what we got. Doesn't see it. Okay, I'm going to replace them with like 100, 110 picofarads. I'll have to see what I've got handy and the most of, and then we'll see if we can tune it in. I guess one of the other things I wanted to check is whether or not we can move the slugs. Let me see. Okay, I'm going to make sure that I can move these cores that are in there with the tool. So they're not frozen up, you know. You do a bunch of work and then the core cracks on you. Let's see if it'll fall in this. There it goes. Okay, that one wants to move. Let's try the one on the bottom. Yep, that was willing to move too. Okay, good. All right then. So the next thing to do is let's dig those caps out of there. And then I got to resolder these wires. And then we'll put the cover back on. And then I'm going to probably, like I say, do probably 100, 110, whatever I have, picofarad caps on the bottom. And we'll just see if it'll tune in. Okay. Got the contact pads pulled out of the way. And we'll see if we can pick this thing out of there. Man, I don't think I've ever seen one all totally blackened like this. It's kind of set down in a recess. There we go. Yeah, I'm going to have to break it in two to get it out. But you can see it's loose here. See, let me show you. So kind of got it moving around here a little bit. See? So we just need to break it in half and pull it out. And it's just mica sheet. I don't want to damage the central tube, obviously. Okay, I broke that one on that side. Now let's break this one on this side. If I can get in there. Okay. Now, there's one half. And there's the other half. Okay, so the focus. So as you can see, the capacitors are out now. We'll take a look at them. Hang on. Okay. All right, so here is the top half that we were looking at. And the two little pads there that you see, that's where the contactors were touching, okay? And I guess maybe one of them goes through a hole to make contact down below. And here you can see the pad that I'm talking about. So that is screen printed silver. Oops, sorry. So that is screen printed silver. And the silver ions migrate from that and go to the other side and short the thing out. And of course, capacitance is there's a screen printed pad there. There's a screen pad here we don't see. I think there's a hole in between that allows the two leaves to connect, one to the top, the other to the bottom, and that's your capacitor. So there's two of them. Okay, let me get the other one. So that's one of them, and here's the other. There's the other. Let's see. And there's the pad on the other side. Okay. So they're out. Now we need to replace them with some quality capacitors. Bear with me. Okay, so I've got a bunch of 110 picofarad caps. I'm going to use these. And I'm going to assume they're both the same or close enough. Like I say, we just have to be able to adjust the coil, the core of the coil to compensate. All right. Now I've seen some people do a fine job of putting the new capacitor inside of the can. I probably could, but I'm just not going to try to make this hard on myself. So I'm not going to try to get it inside the can. Also, that way somebody repairing this in the future can look on the underside and see the two mica caps there and realize, thank you. That surgery's been done. They don't have to think about that being the issue anymore. All right, so I'm going to reattach these wires, these coils. I'll check to make sure I have continuity, and then put the cam back on, put this back on the chassis, and then attach our 2 replacement capacitors that replace these guys. Okay. Hey, fixed. Isn't that tedious? Yeah. Whose idea was this? Okay, you got to wrap on that one. You tack him down. Okay, that one's on. So you got to grab it where the tip of your tweezers are on the same axis as the post. So then you can hold it here and then you kind of wrap it around the post this way, or whichever way is handy for you. But that's how you can do it. As long as you get the part that's been stripped of the enamel down below, you can still wrap the part that's enameled, and that's okay, as long as these stripped parts down below and will make contact in the solder. Tell if I've got that one. Okay, tack that one. I think I've got it okay. Okay. Now we'll check for continuity, right? All this extra space, but I still have to get it all within such a small area. If you see what I'm doing, it almost works out to be the same, doesn't it? All right, let's see. Meter works okay. We got a capacitor between here, not a capacitor, but a coil. There we go, 31.4 ohms. So that connection worked. And now let's get this other one. Hold it like, how can I hold it? I'll just hold it like that. Here and here. 30.8 ohms. Right? Here, let me get a better connection here. There we go. Here and here. Come on. Yep, 30.4 ohms. Okay, good. We got the wires reattached. And we are ready to reassemble the coil housing back on. Well, we got one pencil mark, we got two pencil marks. Okay. Scientific. 1, 2, there we go. Don't be in a hurry, right? What's the down stop? Want that tube to be lined up. Oh, the down stop with this guy right here. Okay. It can't be all the way down there. Make sure the wires don't touch the aluminum housing. Okay. There we go. Okay. Alright, there you go. All ready to go back on the chassis, and then we'll put the new capacitors in there and get that set up. Okay, so we want the green dot up in this position here. And so here we go. Okay, that's snapped into place just fine. Alright. Let me get the wiring redone, and then I got to add our capacitors. So one of them is going to go between these two, and then one's going to go between those two down there. So let me get all this done, and I'll solder that up. We'll take a look. So we're going to definitely have to do an alignment after this, because we've changed the capacitors that are in the IF cans. And like I say, we just hope that we can get there with the range of slug we have, otherwise we have to change capacitors. And I don't want to do that. I really don't. That would be another good reason to not put them in the can, because what if you needed to change them? Okay. Shall I go without a stop, and we'll see if it works? All right, let's see what we get. Done some soldering, so I'm going to use the dim bulb again for sure. Voltage all the way down. Plug it in. Can you see the voltage back here? I guess so. Okay. I'm ready. How about you? All right, let's do it. Power on. 10 volts, 20 volts, 30 volts, 40 volts, watching the amps the whole time. I'm still below 200 milliamps. 50 volts, 60 volts. Am I power on? Yes. $70 volts, 80 volts, 90 volts. We're drawing current, 100 volts, 110 volts. Okay, we're getting noise. Okay, let's get our frequency generator up. 455. We'll go through the coil. Not getting anything. Let me clean the volume control. Wait a minute. What are you doing that for? What's that for? You don't want me to clean the volume control. Okay, well, let me just see if I can do this through the capacitor lead like I did before. Okay, there we go. We're getting the signal. Okay, so let me get that hooked up. So the alignment is so bad we're not able to pick it up that way, but we're going to go through it this way. Okay, so we're getting a signal. Now what we need to do is turn the volume all the way up. This volume control is a little noisy, but make sure I get my 455. Come on. 455. Okay. Let's look at adjusting our IF cans and see if we can get it to come in. Adjusting the output level. So I got the volume turned all the way up. And let's just see if we can start to get it to get a little louder. Here it comes. I'll go to the other side so I'm not doing it all on one side. Let's see, turn the level down. I just notice how much louder it got. Okay, we're going to the top. There you go. Turn the level down some more. It's going down all the way there. Let's try the other side some. I'm going to back it out, see if I can find another peak anywhere. Because I feel like I've shoved the coils into the cores into each other. Okay, that's not helping. Got those cores all the way in. Which makes me think that I don't have enough capacitance here. See if I'm picking up anything. You got a radio station. Let's see here.
Và Hamas được Iran hậu thuẫn. Các vụ sát hại
chính sách đối ngoại và an ninh, đồng thời là Phó Chủ tịch Ủy ban châu Âu nói hôm 31 tháng 7 rằng ông đã đề nghị các nhà lãnh đạo Việt Nam dùng ảnh hưởng của mình đối với Nga để chấm dứt cuộc chiến với Tripp.
Okay, so I'm using external antenna for the best results.
Về những vấn đề, trong đó có cuộc chiến Nga-Ukraine. Giải quyết cuộc chiến này có ý nghĩa sống còn với châu Âu.
It loves me.
Trong tất cả cuộc gặp với người đối thoại của tôi ở Hà Nội, tôi đều thảo luận về cuộc chiến tranh xâm lược của Ukraine.
The problem was Silver Mica Disease. And if you want to not go through all that hassle, remember normally there's two of these. And you got to do that twice. It can be done. And if you want to be able to do it, you can do it. Normally when I do that test, I get the amount of picofarads there, and I can just put in the right size right at the beginning. Usually I don't have to adjust the cores that much. But I wasn't able to get this peaked, and that's why it's so weak. But we definitely fixed it. We're definitely getting a radio signal. Okay, I'm going to tack some additional capacitance on there. I'm also going to clean the volume control. I'll bring you back when I get all that done. So I've got a couple of 20 picofarad caps here. So it'll be 130 is what I'm replacing them with. I have a couple of 50s, but I want to save those. I usually use those for other things. Alright, I'm just going to tack these in. Real easy peasy, like, just because we're testing. I might need to change them again in just a minute. Okay, power's off. Okay, so I tacked another couple of caps in here. I've just done this temporary because we're into the mode of swapping caps out until we find out what works, right? So what I've done is I've got 110s in here and then I've got 20. So we're at 130 across each of these. Now, if it turns out this is right, I've got one more 130. So I may just, unless I'm just going to make this part set, I'll redo this. But at this point, we don't even know if this is going to work. So I'm just going to do this to see if now that allows us to get the cores to peak, and we'll get better peaking out of it. All right, so we're ready to go back to that. Let me go back out. Done some soldering, so we're staying on the dim bulb and all that good stuff. Don't think I have any shorts. I think it all is okay. Yeah, it's not touching the coil in there. I think it's okay. All right. All right, let's just see what we get. At this point, we're just playing, really. I mean, the set's not going to be that great of a set, I don't think. So here we go. Bringing the voltage up. You can see it coming up. There's 30, there's 40. Okay, guys, this is my editing voice. I'm going to try to speed this process up for us a little bit. What we're doing here is, as I mentioned just now, we're kind of playing with different capacitances here. I put in some capacitors in here to raise the capacitance to see if that would allow us to get where we could peak the coils. So I went through the whole deal of bringing the voltage up slow, doing the alignment again, and then testing the results. At the end of the day, it still did not help. I still had to ram the cores all the way in to where they were touching, and so going up didn't help. So let's see what we do next.
tiện lợi an toàn. Điện thoại.
Alright, so what we could do is we could continue to mess around with these different capacitors, and there's ways that we can do that. I don't know if it's going to be worth the time, but as we can see, we did verify the problem was the Silver Mica Disease. I may try to mess with this some more, and if I do, I'll come back and bring you back to show you how we get it fixed, to bring it in a little tighter. Okay, so I've got a couple of 82s in here, 82 picofarads. As I mentioned, I don't have a variable that goes down this low, so we're just going to see how this does. Let me back you up, and we'll power it up and see how this does, if we can get some range. I backed out each of the cores. I think they have been right up against each other. I backed them both out a full turn, and that way I have some room to move it without them moving into each other. Okay, I've got the signal generator tied in directly. Let's see, we are at 455. Okay, I'll switch that on in just a minute. Go ahead and bring the power up. I've been soldering on it, so I'll turn it down. Okay, 40 volts, 50 volts, 60 volts, 70, 80, 90, still under 200 milliamps, 100, 110, right up in there. We're about 150 milliamps. And wait for it to come up. Okay, I'm going to turn the signal generator on. Nice and loud. Let me turn it down. Volume up all the way. Okay, volume's up all the way. Now let's... Okay, turn it down a little bit more. Okay, let's see if we get any response now. We can get a peak. Coming down. What's going on? Okay, let's see what we get. Okay, I'm backing it out. It's getting louder. That's good news. Turn it down. Okay, I got a peak. About there. Got a peak. Right around there. Probably have noisy pin sockets. Haven't cleaned them yet. Okay. I don't need to overdo this now because once I change the capacitors out, if I do it, it probably need to be changed again, but let's just see what we get. I'm going to switch to the coil, see if I can pick up anything on it. Yep, getting something on the coil. Alright, that's probably about as good as I'm going to be able to get, I think. Close enough. Just need to see if we can pick up a signal. Got the Silver Mica Disease taken care of. We probably could do better with matching the capacitors, but I was able to get a peak on both of those, so it means we're actually back into the range it should be. Now it could be I can test these tubes, some of them are weak. I think I got some noise in some of the connections. I know that I would need to change the coupling cap to the audio, although I don't think that's the problem we're having here. But I think we definitely have a problem with the antenna and the sensitivity on that. So there's still some problem with the front end, I think, but the Silver Mica Disease is taken care of. Okay, so it's kind of interesting. It picks up pretty easily here on the higher end of the band. I don't remember what frequency that Vietnamese station is, I'm forgetting, but it's like around 1300 or maybe higher than that. Anyway, it'll pick it up, but then when I move off of it, I really don't pick up hardly anything. I can turn the volume up really loud. And if I get everything oriented, I can sometimes pick up another station, barely, as you heard. But the thing that's amazing is when I get to that station, it comes in really loud. See? Booms in. So what I'm going to do is I'm going to probably check the tubes now, and I may do that coupling capacitor just so I quit worrying about damaging something while I've been playing with it. Okay, so I went in and cleaned the tuning condenser, and it was okay. Just to make sure I didn't have any shorts or contacting, if you will, going on between the plates, because I was getting this weird cutting in and out sound, and you know, I was like picking up a station up here, but I was losing stuff down here, so I was just wanted to eliminate the possibility I was getting some kind of contact between the plates on this end of the banana slicer. So I went in there with my meter and hooked up leads to verify that I was having, you know, no shorting about that. And as I was doing that, I was going in through connecting with my alligator clips to different points here, just to give me an easy way to verify I was connected. And I found something very interesting. This wire wasn't soldered. And if you want to look at that closely, I don't think it was ever soldered. So I wanted to check this on the schematics. That's loose. I pulled the detector tube out just to verify what was going on there, and yeah, it's not connected at all. So let's look at the schematic for just a minute. So what we're looking at there is, pardon me, is right in here. We got this lead coming in from the antennas, and one lead goes to the first tuner, the antenna capacitor, and then the other tuning capacitors here for the oscillator section, and they're connected as you see here, but it says there's a gimmick here. Alright, and then we've got a mica capacitor that goes to spot 1 on the converter, which is there. I found that. And this 2.2 meg resistor is there. And that's there. Now, I never did find the gimmick. And that gimmick could be where that wire is connected, but I've never seen a gimmick where they didn't actually solder it on was it meant to be just wrapped around that post, but not soldered? Well, maybe that was meant to be wrapped around that post, but they've got it stripped back, and I don't think that's right. So what I'm going to do is I'm going to try making a gimmick, and I'll just connect it between here and here. The gimmick is going to have, I don't know, 2 to 5 picofarads. I don't know, maybe even have a, no, I don't think any mic is that low. But I'll just make a gimmick, and I'll connect that to here through a gimmick, and we'll just see what kind of connection we get. Because you may have heard we were hearing some kind of oscillation going on. And of course, that gimmick would help dampen that down. So that could be what's going on there. The other thing that I found, I mentioned testing the tubes, which I did. They were all okay. Interestingly, every one of these were Hallicrafters tubes, except for the rectifier, which was fine. But the audio output tube had a short in it. So that could also have been causing some of the weird things that we were seeing going on. So this one I didn't even get to do in the test. I plugged it in and it said tube had a short in it on my tester. So that was the end of this one. So I had another weak pull that I've put in, and we'll see how it does. I'm sure it'll work. And we just have to be patient with it coming up. And I'll put the detector tube in after I get this gimmick situation squared away, and then we'll see how it performs, see if it does any different, and we'll see what we get. Okay, I've got the gimmick done. I'm just using some 22 gauge wire there. Normally I would make a gimmick with like magnet wire that has really thin insulation on it, but I figured if that green wire was meant to be half of the gimmick and the other half was missing, that it'd be roughly the same. So I just used some wire that you see there, and you twist it together like that. They're not making electrical connection. They're just capacitively coupling to each other. And this is kind of an old radio trick, to create a very small capacitance. I mean, that might be, I don't know, 1.5 to 2 picofarads. Maybe, I don't know. I didn't make it very carefully. A lot of times you can twist and mess with it and, get different results. But anyway, I just thought I'd try it out. So I got it soldered on there. Like I said, that other one was never soldered there. I think that it was bent around it. I think that the lead had been stripped and was stuck through there, but it wasn't soldered. Makes me wonder if maybe, I know that somebody has been in here before because that's been changed. I wonder if somebody saw that wire and removed it and just tucked it in there and then forgot to solder. I don't have any idea. But anyway, we'll just see what we get. There's your basic gimmick. Okay, we'll turn this thing on and see how it performs. Oh, but first I want to put this, change out the coupling capacitor. Since that other tube had a short in it, I'm going to protect my other 50C5 and just keep any DC off of that. So we'll go ahead and change this out. I may go ahead and change the depth capacitor while I'm in it, but I'll leave long leads on it because I can trim it back out. I'm probably not going to leave this thing ready to run, so we'll just see. I'm going to put this in. Okay, so we got the coupling capacitor changed, and I also put in a safety capacitor for that floating ground to be negative to chassis capacitor. I'm not, at this point, I'm probably not going to bother doing the cord sweeping around and all that, because I'm not really planning on this being used very much. But if I end up doing something like that, yeah, I'll rewire how that's all done as I normally do with a polarized cord. I'm not going to do that for this right now. So anyway, got that done. Now what I'm going to do is just, as you see, all of this is just tacked together for this playing that we're doing. I'll just get this back up and see if we can get a test out of it. Okay, I don't have anything hooked up to it in terms of an external antenna or whatever. Let's just bring up the power and see if we get anything at all to start with. Like I said before, I live quite a long ways out of town, so with this being only a, with no amplifier tube in the IF section, I expect it's not going to be a real strong performer. It's definitely meant for being in town, I think. There's 100 volts, 110 volts, there's 120. We're at a little over 100 milliamps, call it 150 milliamps. So I've changed out the 50C5, cleaned the tuner, put in a gimmick, and did the depth capacitor and the coupling capacitor. I checked the rest of the tubes. They're okay. They're very weak, but they should perform. So we'll just let this thing be a little patient with warming up, and we'll see if we can get anything different in terms of performance. It also does not seem to have an AVC circuit, which is probably why that strong station was booming in. Okay, we're going to go to the external antenna. Which means me.
Còn đáp nó có cái này nữa. Quý vị có 3 căn nhà. Quý vị làm 3 cái transform đáp tốn 1.500. Mấy bữa một căn bán được như thường, không có gì trở ngại hết. Rồi quý vị lại mua một căn.
Tubes are probably still beginning to conduct. They're very weak, some of them.
A few years, we can go back 100 years. Well founded mistrust. Well founded abuse. Consistent abuse. Then into broken promises, disenfranchisement.
Our brave military men and women make tremendous sacrifices for our freedom. Patriotic hearts.
You hear how that one actually came in while I was just holding it still. Like I say, I think the tubes are warming up still.
Supporting job transition and job fair programs, veteran entrepreneurship,
or I should say the emissions are improving.
Call 800-851-6067. You'll receive a tax deduction and we'll arrange a...
Learn more at sanjack.edu.
It's definitely performing better.
Every day, Lone Star Chevy's buying hundreds of vehicles, any make, any model, any condition. Coming up with the Beach Boys.
Picking a lot more stations up.
Just 43% of fourth graders in the U.S. are reading at
I wasn't even picking that one up earlier.
Efficiency level. The facts are clear. Our nation is facing a literacy crisis. But rather than solve the problem, school districts across the country are masking it by lowering standards.
I think that disconnected wire here was a lot of it.
For the children they are trusted to serve.
I think I'm getting some interference in the lights.
They rise to the occasion when we set high standards and believe in them. Reversing this trend demands that...
You can see the difference when I let go of it. I'm going to try to tune the antenna. I'm not bothering with the oscillator setting. I guess I could. Was it supposed to be 1620? I can go to 1620 at the top. I'll do it real fast. Take the signal generator, put it at 1620. Okay. Modulation is on. It. I'll go to a station, I'll go to about 1400 to tune the antenna. Close enough. Turn it up. And this is where you do the rocking. Right in there. Okay. Yeah, the front end is so weak on this without an amplifier. It's missing a whole gain stage. Now, it might perform differently in town, but if I hook up me,
We got so completely wrapped up in talking about the bourbon and the cigars, this holiday 6-year soft red wheat bottled in bond. This Fuente y Padron collaboration, the Legend series, we are smoking the cigar, the Jorge Padron on Patience came to us. Like someone played when I played.
The truth and what political violence can really mean. I hope we don't have.
Luật sư rất thì thời gian dành cho chương trình thứ 83, chương trình luật pháp và đời sống này.
We're just told by the other side.
Term limits on the Supreme Court and subjects.
so there you go, guys. I think we did what we intended to do. I can put this back in the case and we can go take it down the street to the park and see maybe if we get a better performance out away from the noise in the shop. And I can even hook it up to a wire that's got some distance to it, and we can just see how it does. But like I say, I mean, I'm a long ways from the transmitters, and we can see how that sounds. But like I say, with this little antenna, it just in missing that gain stage. I mean, it's missing a whole stage of gain by not having the IF amplifier tube. But you know, we plugged this thing in, found out that the capacitors were all shot. It was bad, so bad you couldn't hear how bad the Silver Mica Disease was. So we just took those out, patched in some new ones, got rid of that hum, and then we found out we couldn't hear anything. And because the Silver Mica Disease in there was just so bad. I mean, this is some of the worst Silver Mica Disease I think I've ever seen. The whole top of that thing had turned black. So yeah, and so we diagnosed that, well, this thing has Silver Mica Disease, and you know, if you're just trying to get these things turned around real quick, you know, it's going to take too long to do that. But we wanted to make sure that we had the right diagnosis, so we went through and did the Silver Mica replacement on here and verified that that was the case. It normally doesn't take me as long as this one did to do it, because normally I can, before I pull the capacitors out there that are causing some sparking, is I can get a capacitive measure on there, and therefore I know what size capacitors to replace. In this case, you know, it was so bad I couldn't even get a reading. Now normally I would use a variable capacitor, and I've had some of those. I've been monkeying around with changing its range by putting another capacitor in series. But at the end of the day, I just put in these 82s, and I was able to tune it in, and it's doing what it's supposed to do. Like I say, there's no gain stage in there, so that's going to really hold down the performance. But we got that done. We found out that the 50C5 had a short in it. The rest of the tubes are okay; they're weak, so it takes a while for the emissions to catch up, as you heard. We found that the antenna wire that connects up to the oscillator tuner is supposed to have a gimmick there. Well, that was missing, and I don't know, maybe somebody thought, what's wrong with this, and pulled it out and hooked it up and didn't solder it. So sometime I was getting this microphonics. I could bang on the case and it was causing things to cut in and out. It was because that wire wasn't soldered, and wasn't even crimped. It was just kind of stuck through the hole. And yeah, I don't know if it was made that way and they tried to wrap it around the post. I don't know, but as you saw, what I did is I just put in another wire and twisted it up to make a gimmick and cut it off and tucked it down in there, and it seems to work really fine. So that worked out. And cleaned up the capacitors where I didn't worry about it having any contacting. The antenna coil does have continuity through it. It's not great, but like I say, I think the biggest issue is that lack of IF gain stage that was missing. So hooking up an external wire for this has really been necessary out here. But anyway, the speaker's in pretty good shape. Anyway, so I think what I'll do is maybe try to trim some of this stuff back up, and we'll put it in the case, and we'll just see what we got. Now, the wire is non-polarized, so what I'm going to do is, just for my own use, I'm going to mark which end of this is going to the to which connection, so I can be sure that I plug it in with hot going into the rectifier tube and not going to the you know, not going through here to here. So I want the hot to not go to the switch. I want it to go to the rectifier. So then this is neutral that comes to the B minus, and then the B minus then goes through that safety capacitor you just saw me replace and put it to the chassis. So I'll just put a mark on here for now, and then that'll allow me to maybe take it down to the park and see if it does any different. I kind of doubt it. I might get less noise interference. I might get a little slightly better reception. I might hook up a longer wire to it, but we can just see how it does. But I mean, you don't see a whole lot of all-American 4s, and I think this is probably the reason why. But you know, it's kind of been interesting to see this one, especially to verify the, you know, seeing it as bad as Silver Mica Disease as this had, and verifying we got the diagnosis right. And it's up to you whether you want to do the effort, but I showed you how to do it on this particular cam. So I'll get this kind of tucked around, tuck it into the cabinet, and we'll see what we do after that. So hang on. Okay guys, so here we are out at the park, away from the house, all the noise of the shop and switch mode power supplies and all that sort of stuff. So we brought this little 4-tube radio out. As I mentioned before, I'm kind of way out in the sticks. And I've got this just on the internal loop antenna. We'll just see how it does. See if we can pick up anything at all hardly out here. Okay, so I've got a wire hooked up here that is, I measured it's about 15 feet long. I've just got draped over the bushes all around here. I'm just going to connect this up and see how that affects the reception out here.
Back that I was going to go work for Trey Stone again, because I worked for him, you know,
pretty well
about 15 years ago, and Trey Stone is the
Mike Feigen, Design Tech Homes, DTH.com, hosts a home buying evening. Go colder and warmer.
And use less energy doing it.
So your comfort goes up.
And your energy bills go down.
All year long. Wow!
So there you go. You know, would you call it a great performer? Well, probably not. But this was a very inexpensive radio, I'm sure. They may have sold this at 5 and dimes, you know. It was meant to be just a little, I guess, kitchen radio or bedside table radio back in the, you know, the days of the suburbs and things like that. Like I said, this is from 1953. So anyway, we went through and just kind of see if this thing would work and how it would cooperate. We found we ran right into, first of all, filter hum, which was not surprising. But then we ran into the Silver Mica Disease, and probably one of the worst cases of Silver Mica Disease I've ever seen. And so my point at that point was saying, you know, this radio is probably not, you know, I hate to slam it, but it's probably not worth that much effort to put into it to see about getting it back into shape. But we thought, well, you know, for the sake of what we're doing here, let's see if we were right about the diagnosis. And so we went into the Silver Mica Disease on this, and it was one of the worst cases I think I've ever seen. The capacitor change out on this was not particularly difficult. It wasn't hard to get the capacitor out. It wasn't buried inside of some injected molded parts of the capacitor can, which it is in some cases. However, it was so badly gone, I really couldn't tell what kind of capacitor value was there. I did some substitution and found one where I could get a peak on the coil, and that was able to do it for us. Could do the variable capacitor trick, but for it to say, well, it needs to be somewhere between an 83 and a 92 or something like that, only had specific options to go with. So I had a 82, or I had a 100, or I had a 110, and so it's kind of like which one will work. So you just do it with substitution, and it worked. And so we got the IF tuned in, and then we went through and did the rest of the work on this. We changed the audio coupling capacitor and the depth capacitor, but I didn't do any others. There's a couple of other capacitors in there. I didn't do the power cord with the polarization. I didn't put a fuse in, any of those things. So this is not restored. This is a good restoration candidate if somebody wants to take it from there. But this is probably one where somebody probably would have put this in the parts box early on when they sampled the Silver Mica Disease, and so you can kind of make your own choice whether or not that's something you wanted to pursue on it, and you can see kind of how much work was involved. It's up to you whether you want to do it. It's kind of a neat radio. It looks like it would be a pretty neat candidate to repaint, perhaps. I'm not even sure this is the original color. I've seen pictures of these things painted red, and they've got the letters redone in gold. It'd probably look pretty cool. And, it would work pretty well for being in a city, or if you want to hook up a line to it, it works pretty well. So anyway, that's it for this one. Appreciate you guys watching, hanging around. All the kind comments, I really appreciate those. Until next time, see you. Thanks. Bye. By the way, in the last video with the Zenith, did anybody notice that we had a visitor? I'm going to put the Zenith video up here in the corner, and I'm going to circle an observer we had in the backgrockground. I didn't notice it in editing, but somebody pointed it out to me after the video came out. So there he is. Hey, little guy. All right. See y'all later. Bye.